Okay, so here is the review for test number 4 over chapter 7. First question, write with positive exponents this expression and simplify if possible. So first, let's change this negative exponent into a positive one. So you do that by doing the reciprocal of the base. The base is the 512. The base is what's raised to an exponent. So if it is not a fraction, you put it over 1, and then you do the reciprocal, which is 1 over 512. When you do that, the exponent switches to positive when you flip around the fraction like this. So in the next step, we're going to try to simplify. How do we simplify? We're going to have to rewrite the denominator as having a radical. So the 512 stays inside of the radical. Outside, always the number that is the number that is on the denominator of this exponent that looks as a fraction of this rational exponent, it's going to be the index of the radical of the root. The 4 can go in two different places. The numerator, you may write it on top of the 512, but see, I don't think this is what you want to do, because this is going to complicate things more due to the fact you're going to have to do 512 to the 4th power, which is going to be a big number, and then find the cube root of that number. So I think it's better if instead you write the 4 on the outside, but technically you can write it either inside or outside, but it's easier if you put it on the outside. So what you're going to do next is first solve the inside of this parenthesis. So let's find what's the cube root of 512. So we need to figure out what number multiplied by itself 3 times equals 512. So for example, what if we do 6 times 6 times another 6? That's 216. That means it has to be a number bigger than 6. 7 times 7 times another 7, 3 times, 343, so more. 8 times 8 times another 8, 512. So that's the cube root of this one is going to be 8 times 8 times 8. That's the inside. Okay, so in parentheses, you're still going to have the 4th on the outside. This is going to be 8. And then 1 over 8 to the 4th power, all you're going to do is raise to the 4th power this number. So you're going to multiply the 8 by itself 4 times. 8 times 8 times another 8 times another 8. So 4,096. So that's what's going to be. Okay. And this would be the final answer. Okay. So continuing with problem number 2, this problem says, let me move this on here. Use the properties of exponents to simplify the expression. Write with positive exponents. Assume that all variables represent positive real numbers. So first on the numerator, the two b's are multiplying times each other. Okay? So remember the rule. When you're multiplying two bases and the bases are the same, you can add the exponents. So the bases here are the b's, they're the same. So you write the base once, and then you write the new exponent of that base is going to be the addition of these two exponents. Right now we're going to leave the denominator the way that it is. We'll figure what to do with that next. So here, 1/4 plus 1/4 is going to be 2 over 4. Okay. Which 2 over 4 can be simplified to, if you divide both numbers, if you divide them by 2, that's going to give you 1/2. And then you have this division. So imagine that in front of this these, in front of every letter that apparently has no coefficient, there's a 1 at the front. In this case, this is a -1, right? So divide 1 by a -1, that's going to give you a -1. And then what to do with the exponents on the bases that are dividing by one another. B to the 1/2 divided by B to the -1/2. You're going to subtract their exponents. When you're multiplying, like at the very beginning over here, you add the exponents. When you're dividing and the bases are the same, you subtract the exponent from the numerator minus the exponent from the denominator. And the exponent of the denominator has a negative sign, right? I forgot to put it in. So it's 1/2 from the top minus, because you're always supposed to do that operation, subtracting, minus negative 1/2. So you have negative 1b raised to the 1/2 plus 1/2. Why? Because you're supposed to multiply these two negatives. Negative times a negative gives you a positive. And this is going to be negative 1b raised to the 2/2, right? 1/2 plus 1/2 is 2/2. And so we can write this in simplified form. We don't need to show the 1. You can just leave negative b raised to the first power, because 2 divided by 2 over here is going to be 1, but you know you don't even need to write the exponent 1. We know there's a negative 1 in front of the b. We know there's a 1 as the exponent on the b. Okay. And that would be the answer for this one. So that's the simplification. Simplifying by factoring this number. So we want to find a way to rewrite 90 as the multiplication of two numbers. One of them you wanted to have a perfect square root, and the other one you wanted not to have a perfect square root. So 2 times 45 gives you 90, but none of them have a perfect square root. 3 times 30 gives you 90, but none of them have a perfect square root. So you have to think, what else could you use? Divided by 4, nope, not divisible by 4, by 5. 5 times 18 is also 90, yes, but none of them have a perfect square root. So divided by 6, 6 and 15 gives you 90, but none of them have a perfect square root. 90 divided by 7, nope. By 8, nope. By 9, you know 9 times 10. 9 has a perfect square root, and 10 does not have a perfect square root, and 10 cannot be broken into any other two numbers that might have a perfect square root. See, 10 can only be broken into 1 times 10 or 2 times 5, but that is it. None of these ones have a perfect square root except for the 1, right? But that's, remember that that's not important. The ones that you don't want this 10 to be broken into is other numbers different than 1 that might have a perfect square root. So we're going to rewrite square root of 90 as 9 times 10. So if I rewrite this as the square root of 9 times the square root of 10, square root of 9 is perfect, it's 3. The square root of 10, there's nothing you can do with it, so you just bring it down, and that would be your answer. 3 square root of 10. Okay? That's the simplification. You don't need to leave a space in between 3 and square root of 10. They're a single number altogether. Okay? This next one, simplify. Assume that the variable represents a non-negative real number. So break it. This one has to do with some property that I did in the previous problem. Break this into smaller pieces to try to make it simpler for yourself. And do it separately like this. Square root of 25, it's perfect, is 5. Square root of x to the 7 is not perfect. How do you know? Because 7 divided by the index that supposedly is over here on the top, even though you don't see it, you know it's a 2. 7 divided by 2 is not a perfect division. So you're going to have to divide 7 by 2. So you're always, when you see that the exponent cannot be divided by the index, you're going to do this division by hand. You're going to say 2 times what gives you 7? Well, nothing, right? But the closest could be 3. So 2 times 3 is 6. 7 minus 6 is 1. This represents how many x's you're going to write outside of the root. X to the third is going to go outside. And this represents that you're going to leave one x, x to the first power. You don't need to show the 1 on top. That one is going to stay inside of the root. So then x to the third, the answer for this part, it's going to be x to the third, the square root of x by itself. So all this is the answer. 5x to the third square root of x. Okay. The next problem is about working it into smaller pieces also. Two numbers that multiply together give us 75. Could be, what about 3 times 25? 3 times 25 is 75, and 75 has, and 25 has a perfect square root, while the 3 does not. So that's your perfect combination. 2 times 25, 25 has a perfect square root, while 2 does not. And for 27, 3 times 9, square root of 9 is perfect, is 3, and 3 doesn't have a perfect square root. So let's just rewrite these numbers as 3 times 25 minus 4 times 2 times 25 plus the square root of 3 times 9. So see, these numbers were not that difficult to figure out the numbers that we needed to rewrite them as. So what to do next? The numbers that have a perfect square root, you get to write them on the outside of the roots. But obviously you're going to write outside the answer of the square root of those numbers. Don't just copy the numbers. You have to do the square root of those numbers and write it outside. So square root of 25, it's 5, minus 4 times 5, that's the square root of 25, square root of 2, plus the square root of 9, which is 3, square root of 3. So now we simplify. 4 times 5 is 20, square root of 3, minus 4 times 5 is 20, square root of 2, plus we bring down this 3, square root of 3. So we combine like terms. Which like terms we can combine? The ones that have the same number inside of the radical, which are these two. So 20 plus 3, 23, square root of 3 minus 20, square root of 2. And this is it. There's nothing else you can do. You cannot simplify this anymore because this one has a square root of 3, this one has a square root of 2. They're not like radicals, so you just stop right there. Okay? So the next problem it's about multiplying and then simplifying if possible. So remember that you're supposed to FOIL this. You're going to expand this expression. So you're going to copy this expression twice. Why twice? Because the exponent is telling you to. So square root of 3 times the square root of 3. When you do square root of 3 times the square root of 3, you know there's a little shortcut we use. When the inside of the radical is the same, and we're multiplying a square root times another square root 2 times, the radicals cancel, and the answer is just going to be 3. So that's what the answer is going to be for the multiplication of those two. Then you do square root of 3 times negative square root of 10. So square root of 3 times negative square root of 10. Sorry, I was going to put a 3. Where's my toolbar? Over here. Times negative square root of 10. So here the radicals are not the same inside, so you're not going to cancel the radicals. You're gonna, well, first of all, I guess multiply the signs. Positive times a negative equals a negative. Square root of 3 times 10 is 30. You're gonna multiply the two numbers inside. Even if they're different, you can multiply them as long as both are inside of radicals. Then we can, so we already did square root of 3 times this 2. Square root of negative square root of 10 times the square root of 3. Something similar as the previous multiplication. Negative times the positive, negative square root of 30. You multiply the 10 times the 3. So negative square root of 30. and then negative square root of 10 times negative square root of 10. Negative times a negative, it's a positive. And the square root of 10 times 10, which that is going to give you the square root of 100, which you know that's 10. Basically, right? Positive 10. So then now what do? Simplify. Collect like terms. So we could combine, let me see what that, okay, this one. We could combine the 3 with the 10, and we could combine the negative square root of 30 with the negative square root of 30 because both have square roots, right? And both have the same number inside. So then 3 plus 10, that's going to be 13. Both are positive. And then you have to combine negative square root of negative 1. Imagine that there is a 1 here at the front and also here, even if you don't see any number. So that's going to be negative 2 square root of 30. This 2 in the middle. Okay? And that would be your answer. There's nothing else we can do. Okay. Next problem is very similar to that one, except that this one has it's already expanded. You don't have to expand it. You're going to multiply and simplify as much as possible. So 5 square root of x times 3 square root of x. So you get to multiply the two numbers on the outside. Those two you can. This one times this one, 5 times 3 is 15. And then you do square root of x and square root of x. Remember the shortcut? These two have the same thing inside of the radical. So then you cancel the radicals or the square roots, and you just bring down the x over here. So 15x or 15 times x is going to be the answer for the multiplication of these two. So you write here 15x. Then we do 5 square root of x times a negative 4. So be careful here, because the negative 4 doesn't have a radical. So the only thing you can do is multiply the 5 times the negative 4, which is negative 20, and just rewrite the square root of x. Then next, 9 times 3 square root of x. So again, multiply this 2, 9 times 3, 27, and just bring over the square root of x. And you put a plus because your multiplication is positive. Then 9 times a negative 4. You're not subtracting, you're multiplying. So that's going to be negative 36. And now let's combine like terms. So 15x can be combined, no, not really. I was going to combine it with this one, but this one doesn't, the negative 36 doesn't even have an x. So the only two that we could combine are these two in the middle. Why? Because both have the square root of the same radicand inside. So these two right here, we can combine them into negative 20x plus 27x, subtract them, and that's positive 7 square root of x. And then you bring down, obviously here, the minus 36. But other than that, I think that's all we could do for this problem. The three terms that we have here that I'm putting in this box, they're not like terms anymore to each other, so then there's nothing you can do. You cannot combine the 15x and the one that has the 7 square root of x, because the first one doesn't even have a square root, and the 36 doesn't even have a variable, so that's it. Number 8, rationalize the denominator. So you're going to multiply top and bottom of this fraction to rationalize. That's the process of rationalization. You use this when you want to get rid of the radical on the bottom of a fraction. So you get the expression on the bottom, and you use it to multiply numerator and denominator of this fraction. So square root of 10 times 7 is going to be the square root of 70. Over here, you know that when you're doing the square root of 7 times the square root of 7, if the inside of the radicals are the same, they cancel, and you just bring over the 7. Okay? So then square root of 70 over 7. I don't think we can simplify 70 in any way. If, let's see, is it divisible by 2? Yes, but 2 and 35 don't have a perfect square root. Divisible by 4? No. Divisible by 5? Nope. No, this number is not going to be divisible by any number that may give you a perfect square root, so this is it. This is the answer. You can try to see if you can factor the number on the top, but this one's not going to be one that you can simplify more. But always try to see. But just thinking of the numbers that this can be divided by, it's not possible. Then solving this equation. So to solve an equation like this, I want to solve for x. So I want to raise to the second power both sides of the equation. Why? Because I know that the operation, that it's the opposite of the square root, and here what I want to do is bring the x minus 15 without the root, without the radical, and the only thing that can cancel it, it's raising to the second power that side. But in an equation, whatever I do on one side, I also do on the other one. And then I just simply solve for x. Oops. Went over too much to the right. So plus 15. So x is going to be equals to, that's 11, 4, 5, 51. And then remember, in this kind of equations, you always need to check your answer. Always, always. So square root of x minus 15 equals x. You check, obviously, with the original equation, right? So let's see if I put the x to be 51, and then I do minus 15, and this looks as a 6. It's a 15. Let's see. If I subtract 51 minus 16, that's 35. So then, what number did I say here? 35. So is it true that this side on the left is the same as this one? Let me just double check that I did no careless mistake. 36 plus 15. Yeah, it's 51. I was checking this. So when you substitute 51 into this x, 51 minus 15, oops, that's the thing here. This was 36. Probably put something wrong on the calculator right now and I got a 35. So it was 51 minus 15. This gives me 36. And you know the square root of 6, the square root of 36 is 6. So 6 is equals to 6. So that means this is the solution, this is the answer. If it really would happen, something like what happened to me, that I did, assuming that I did no careless mistake, because I just did one right now. And when I plug in the answer to check in the original equation, I do get these two sides to be the same, then this wouldn't be the solution. I mean, if I get these two sides not to be the same, assuming I did no careless mistake, then you would say that this problem has no solution. But this one is the true solution. It is. Okay, because it matched over here. These two numbers are equal to each other. Sorry about that careless mistake right there. Then subtracting. So you're going to subtract two complex numbers. Remember, the complex numbers are the ones in the form a plus bi, right? If you remember that. So the most important thing here that you need not to miss is that you need to distribute that negative over. So the first two terms, bringing them the way they are, no issue with them. But then here, negative, a negative sign times a positive 5, negative 5. A negative sign times a negative I, positive 8i. And then combine like terms. The 2 with the negative 5, the 8i with the positive 8i. So then 2 minus 5, it's going to be negative 3. 8i plus another 8i, 16i. And that would be it. Okay, so you just distribute the negative and collect like terms. And that's your answer in the a plus the a form. The a is the negative 3, the bi is the 16i. Okay. This one here, multiplication, we kind of did something like this except without the i's probably, but it's the same thing as the FOIL method. So square root of 3 times the square root of 3, it's going to be just 3, because you know, based on the shortcut we've been doing, if the inside is the same, cancel the roots, and that's the answer, 3. Then square root of 3 times negative 9i. You cannot multiply the 3 and the 9 together because the 9 is not inside of a root and the 3 is, so they're not the same thing. All you can do is write these three things side by side. Negative 9i square root of 3. Just like that. Then 9i times square root of 3. 9i square root of 3. You do the same thing, but this time this is positive. And the last one, 9i times negative 9i. 9 times negative 9, negative 81. I times I, it's an I squared. So if I look for like terms, well, the 3 right now doesn't have any like term. These two, I can combine them. They're the same exact term, but they have opposite signs. So in reality, they cancel each other out. I bring down the minus 81, and if you recall, I told you once that every time you have an I squared, that I squared has to be replaced with the number negative 1. Always, always. You have to remember that. So negative 81 times a negative 1, you're going to multiply these two numbers, gives you positive 81. So 3 plus 81, 84. This one, you're going to expand it. Write it twice and do the FOIL method. So kind of like the previous one. 5 times 5, it's going to be 25. That was an easy one, right? Then 5 times negative 6i, it's going to be negative 30i. Then negative 6i times 5, the same thing as the other one but flipped, still negative 30i. And negative 6i times negative 6i, negative times a negative, it's a positive, 6 times 6 is 36, and then I times I is going to be I squared. So plus 36 I squared. You bring down the 25, then we combine these two in the middle. So negative 30i and another negative 30i, you add them up and you keep the sign. Negative 60i plus 36, and then recall that the I squared can be replaced with a negative 1. So positive 36 times a negative 1, it's a negative 36. So you can combine the 25 with the negative 36. So that's going to be 25 minus 36, negative 11. 25 minus 36. Yes, I just wanted to make sure. Minus 60i, because there's nothing you're going to do with that one. And that would be your number in A plus BI form. This last one, I think it's almost the same as this one, except this one you had to know that you had to expand it this way. This one is already expanded like that. Okay. 4 times 4 is 16. 4 times negative 8, negative 32i. 8i times 4, positive 32i. And then 8i times negative 8i, negative 64i squared. So 16, the 2 in the middle, what happens when you try to combine them? Negative 32i plus 32i, they cancel. You bring down the negative 64. Remember what happens with the I square? The I squares need to be substituted by a negative 1. So negative 64 times a negative 1 becomes a positive 64. And your final answer is going to be the addition of this 2, which is going to be 10, 7, 80. Right? And that would be your answer. And that's it. This is the review. Okay.